Chapter 2, Statistical Presentations and Graphical Displays. PowerPoint by Denise Barber, and speaking is Abigail Baker. Frequency distributions. It's a table in which possible values for a variable are grouped into classes, and the number of observed values which fall into each class is recorded. You record that by doing group data, which is data organized in a frequency distribution, and ungrouped data is every observed value of the random variable that is listed. Now let's talk about class intervals. Stated class limits. The lower and upper limits indicate the values included within the class. Exact class limits, which are the class boundaries, are the specific points that serve to separate adjoining classes along a measurement scale for continuous variables. Class intervals identify the range of values included within a class and can be determined by subtracting the lower exact class limit from the upper exact class limit for the class. Class midpoint can be determined by adding 1/2 of the class interval to the lower exact limit of the class. So the way you can figure this out is with an approximal interval equals largest value in ungrouped data minus the smallest value in ungrouped data divided by the number of classes desired. Unequal class intervals, data that are distributed in a highly non-uniform way. Histograms and frequency polygons. Histograms, a bar graph of frequency distribution. Frequency polygon, a line graph of a frequency distribution. And to the right, you will see an example of both. Frequency curves, a smoothed frequency polygon. Part 1. Symmetrical distribution, positively skewed, non-symmetrical with the tail to the right, negatively skewed, non-symmetrical with the tail to the left. Frequency curves, Part 2. Platycuric is flat with the observations distributed relatively evenly across the classes. Leptocurtic is peaked with the observations concentrated within a narrow range of values. Mesocurtic is neither flat nor peaked in terms of the distribution of observed values. And below each explanation is an example of each curve. Cumulative frequency distributions. They identify the cumulative number of observations included below the upper exact limit of each class in the distribution. The graph is called an ogive, and it indicates the cumulative frequency below each exact class limit of the frequency distribution. The smooth line graph is called ogive curve, and below we listed an example. Relative frequency distributions. One in which the number of observations associated with each class has been converted into a relative frequency by dividing by the total number of observations in the entire distribution. Advantage. Cumulative distribution and the ogive for such a distribution indicate the cumulative proportion, or the percentage, of observations up to the various possible values of the variable. Percentage, the cumulative percentage of observations up to a designate value of variable. The and under. Class limits that are given in computer-generated frequency distributions. The stated limits are also the exact limits that define the class. Example, 5 and under 8, or 8 and under 11. Stem and leaf diagram. A relatively simple way of organizing and presenting measurements in a rank-ordered bar chart format. Most popular technique is the exploratory data analysis, which is concerned with techniques for preliminary analysis of data in order to gain insights about patterns and relationships. In contrast, confirmatory data analysis, which includes the principal methods of statistical inference. Dot plots. Similar to a histogram in that a distribution of the data value is portrayed graphically. The difference is the values are plotted individually rather than being grouped into classes. Pareto charts. Similar to a histogram, except that it is a frequency bar chart for a qualitative variable rather than being used for quantitative data that have been grouped into classes. Bar charts and line graphs. A bar chart depicts the time series amounts by a series of bars. A component bar chart portrays subdivisions within the bars on the chart. Line graph portrays time series amounts by a connected series of line segments. There has been an example of both posted on this slide. Run charts. They are plotted data values in the time sequence order in which they were observed. When lower and upper limits for acceptance sampling are added to such a chart, it's called a controlled chart. Pie charts. A pie-shaped figure in which the pieces of the pie represent divisions of a total amount, such as the distribution of a company's sales dollar. A percentage pie chart is one in which the values have been converted into percentages in order to make them easier to compare. Pie chart example is listed to the right. And that's the end of our Chapter 2 PowerPoint. Thank you for joining us. We appreciate you.